Hello, I'm Professor Ben Sebitosi from the Center for Renewable and Sustainable Energy Studies, Stellenbosch University. This is our presentation in our series for the eThekwini municipality. This presentation is on heat pumps. We start with the overview. We have the background to the technology. We look at different types of heat pumps. We look at power consumption, terms like coefficient of performance, look at advantages and disadvantages of heat pumps, how to size and how to maintain the systems. This is the general overview of a heat pump. It has various applications. It can be used for hot water. It can be used for space heating. The world market usage for heat pumps is not very large, but these are the major markets. Japan is the biggest, and China, of course, Germany, USA, and the annual total market is about 4,500 million euros. There are funding programs that have been initiated by ESCOM for heat pump rebate program. There is also another program by the UN Forum for Convention for Climate Change in the eThekwini municipality that has supported heat pumps. Electric heat pumps generally use the same principle as the refrigerator. It's just the process is reversed. They use electricity, so they are not like solar water heaters. However, the amount of electricity they use is much less than what is used by the traditional resistance heaters. The principle mainly can be likened to a fuel truck which delivers fuel from one point to another. The efficiency is the amount of fuel the truck uses versus the amount of fuel it delivers. So we talk of coefficient of performance. Under normal circumstances, heat moves from a hotter body to a cooler body. But in the case of a heat pump, we must move heat from a cooler body to a warmer body. So external work must be applied. And the maximum efficiency is determined by how much energy we put in compared to how much we get out. And is calculated by the Carnot cycle. So it's called coefficient of performance, which is the amount of heat delivered to the hot tank or to the hot space compared to the work required to do the job. This schematic illustrates the source where we extract the energy from and the power we need to run the pump and the delivery. And this is the coefficient of performance. The key components of the heat pump are the evaporator, expansion valve, compressor, condenser, and the working fluid. The easiest way to comprehend or understand this system is by understanding that when liquids evaporate, they require energy to evaporate. So they pick up energy. And when they condense, they give up that energy. So at your source, you must evaporate. Use an evaporator to pick up that energy. Compress the fluid that you are using, and then condense into liquid, lose back the energy. So heat pumps use a working fluid. It draws heat from the source through using an evaporator, and it's transported to the condenser where it is dissipated to the load. The compressor compresses the working fluid, raises the temperature to a higher temperature, and is transferred across to the condenser in the hot water tank. The phase change of the working fluid is the latent heat, which has a very high value, and that's where you have disproportionate amounts of heat per kilogram compared to specific heat capacity. This is the general Carnot cycle, which is a standard Carnot cycle. You have the evaporation system, compressor, condenser where heat is given out. Then you have a throttle valve, which repeats the cycle again. We are going to look at sources. You can source the energy from a ground source, air source, or water source, and to load the required equipment. In this case, you have the air source. Outside, heat is picked up and delivered to the interior. Then we have the ground source where heat is collected by the working fluid from underground. And then you have a water source. So those are the three main areas. Household heating and cooling can be applications. In summer, for example, the temperature underground remains constant. And that temperature can be picked up or used to cool the inside. Likewise, in winter, you can use the same constant temperature to warm the interior. The alternative option can be used when your source is a water source. There are some useful clips, video clips on this website that are important. One of them is heat pumps, an introduction. How a ground source heat pump works is another one. You can Google them. Sizing. Choosing the correct size of tank is the first important step. Again, using an experienced service provider is recommended. The equipment is normally standard equipment. You look at the label or the product on the web, the literature on the product manufacturer. And finally, look at water heater models with the first hour rating that closely matches peak demand. However, it is most important, like we mentioned in an earlier video, that reduction of usage is very important before you go to sizing. If you are going to buy any system like a heat pump, ask yourself, how well is the water being conserved in the house? Advantages of heat pumps are the heat is production is fully controllable. It can be used as a hybrid in conjunction with the traditional electric heaters. It's renewable because the heat in the environment is created by the sun. The sealed units don't require any user maintenance, and the other maintenance procedures are really low, just like a refrigerator. Disadvantages include installation costs. External costs, units can be noisy. Matching capacities can be problematic because they are not made to measure. They are off-shelf units. Output decreases with, of course, if you're in winter, it's more problematic than when you're in summer. And radiator outputs need between 3 to 5 times, between 2 to 3 times greater when you're in summer. The water cannot be heated to more than 40 degrees under normal circumstances, so you need additional heating. Maintenance, regular maintenance is key, but service providers are the best option for you. And lack of service obviously has problems. Areas of concern: filters, coils, vegetation that clutters around the collections, the collectors, the outside, routine checks of fans for jamming, ducts, seals, airflow, using the correct refrigerant, checking for leaks, electric terminals, tight connections, lubrication of motors, verification of electric controls, thermostats, and any incident of anomalies. There are frequently asked questions that we want to go through briefly. What is the difference between a heat pump and a solar water heater? Well, a solar water heater uses solar radiation and is totally electric power free. On the other hand, a heat pump uses electric power. If the solar water heater if the solar water heater does not use electricity, why do we stick on to the heat pump? There are situations where you are forced. If you're in a block of flats, you may not have an opportunity to put a solar water heater on your roof because you don't have a roof. If the heat pump uses electricity, why not simply stay with the tree? A heat pump functions by transporting heat from a source, such as air, and delivers it to the water. The amount of energy required is a lot lower than the traditional heater. That's why they both use electricity. However, the traditional heater uses a lot more electricity. Will the pump work in winter? Yes, it does, but it's less efficient. Would the pump require additional traditional electric heater? Yes, it does, especially because the heat pump does not exceed 40 degrees, and you normally require the water to be about 55 to 65 degrees. But the amount of additional energy the heat pump gives you will help reduce your electricity bill. Again, there is a bibliography, Introduction to Heat Pumps, that you can find on this website. And thank you.